Okay, here we go. Let's do another one of these things. This one's cute because it doesn't tell us the mass burn rate. Okay, it doesn't say how many kilograms per second, right? Now we do know this and we know this, right? So I think we can figure out our initial mass is 6.60, right? And then subtract 4.80, and our final mass is 6.6 minus 4.8, 1.8. Right, so here's our initial mass, there's our final mass. Okay, let's see. Oh, and then now we got to figure out the thrust of the engine. So let's go force times time is mass delta V, right? So we got the delta V, we've got the time. We're trying to find the force. So force times 12.3 equals 4.8 times 712. Right, so again, we can still do this even if it's not they don't tell us the kilograms per 1 second. Here they're telling us 4.8 in 12.3 seconds, right? It still works, right? This is, I mean, you know, it's just a different thing, right? It's not 1 second, it's 12.3 seconds. So now we're set. We'll go 4.8 times 712 divided by 12.3. And that's 277.85. I'll say 854. That's so many sig figs here. Okay. So I'm going to use this. I'm going to use these masses, right? I'm going to use this guy to figure out the acceleration of it, right? So initial and final, right? The initial, you've got the force of the engines up, so you got 277.854. Oh, we got to figure out the weight. Let's see. What's the weight? The initial weight is 6.6 times 9.81. Wait, hold on, clear. I'm going to store that thing in the variable a just for kicks. Okay, so now I'm going to go 6.6 times 9.81. 64.746. Right, so that's the weight. 64.746, and that equals 6.6 A. That's a decimal point, right? Okay, so now I'm ready to go. I'm going to go alpha A, whoops, alpha A minus the answer I just got. Is that 213 divided by 6.6? It's 32.3 meters per second. Meters per second squared, sorry. There we go. And then to get the final, we're going to do the same thing, right? We're going to have the same thrust, 277.854. So we're assuming the rocket thrust stays the same, right? But now we got to figure out what is 1.8 times 9.81. That's the weight, the force of gravity, right? Because the final mass is 1.8. 1.8 times 9.81. 17.658. Whoops. Unmatching parentheses. That equals 1.8 times A. Okay, here we go. Let's see, that's 17.658. Okay, so here we go. We're ready to do this. I'm going to go alpha A minus the answer I just got. So that's 260.1956 is this side. And then divide by 1.8. 144.6, so 145. All right. There you go. So the trick on this one was just this. Okay, instead of just saying that the force is equal to the mass burn rate times the exhaust velocity, it told us how much time it took to burn the fuel. So we put that in there, and that was the only difference. Okay, I'm going to do another example where we have to actually sort of figure out what the final velocity is, and that gets a little bit tricky.